Guys, so just 5 minutes of your time. We'll be briefing about AutoAuto. Since we have less time, I'll be concising about it in a few minutes. So AutoAuto is basically a dedicated vision-based robot that has its wheels, and it has one motor driver to control the wheels and the steering. Basically, underneath the cover, you have like a Raspberry Pi in short. That's a 3B plus model. The basic Raspberry Pi basically, as you know, has 15 pins and can connect fully. It's like the brain of the computer, let's say. And we have a Pro microchip that basically acts, let's you can say the heart of the particular computer. You have a storage device that basically gathers the data from MPU 6050 sensor that has three linear sensors, accelerometer, gyrometer, and you get, let's say, accelerometer. We get X, Y, Z and values. These values are then incorporated through the Pro microchip and are like stored in the PC, which is then reflected onto a whichever, let's say, you have coded it up in the particular native application, or you are storing directly and you are calculating it based on it. Then you have gyrometer, from which you get the three values, that is X, Y, and Z values. Apart from that, we have temperature sensors alongside it. We have a LiPo battery to power it up. And apart from that, we have the Raspberry Pi, which is 3 model. It has basically the specs are pretty good, so we can use Ubuntu. It is preload. It comes preloaded with the application software. So basically, I'll give a short introduction about it. Let's say it's basically a comprehensive curriculum for all levels. It's basically used for like, let's say you have computer vision as, let's say you're interested in computer vision. How do you identify this lane detection, object detection, and all the like detection modules that come over there, which are incorporated inside it? And so basically, it's like a hands-on mastery because you are given the platform. You just need to code in. You can even code in Python, C++, and also Java. So these are the like you are free to use anything you want. You can, if you want, like you could just put your code in the browser, and it's like a web-based learning platform also. So we have courses dedicated for explaining how the AutoAuto works and its integrated software. They also have a custom-based PCB layout that basically controls how the overall robot functions, and the four-axis drive wheels. So it can be basically AutoAuto is, can be used for swarm robots. Swarm robots basically, as Ashwin had briefed about it earlier, we can use it like multiple interconnected robots connected together to perform a certain action. Let's say mapping the environment, which is pretty big, and you have even like Martian terrain exploration. Apart from that, basically AutoAuto has like something. Let's say which is interconnected between let's say a few AutoAutos, and we have body that is stronger that it initializes it, and we have like for control flocking and collaborative task allocation, which basically incorporates vision tasks and seemingly maps the whole environment. Since the body has a high camera that is like on the top, very top of it. So basically, it uses a UDP port on the Raspberry Pi, and it's displayed on the display panel that's given. So you just mount it on top of it, and you have the all setup ready. And after that, let's say a technical dive, how the computer vision usually works. Let's say how many guys have people like OpenCV over here? Okay, or YOLO, let's say. So in our YOLO. So basically, you can also like it's similar to a YOLO or let's say OpenCV. So basically, you have integrated patterns. Like DeepWay uses it. So what it does basically, it identifies the particular color patterns or the range, and then based on it, identifies okay which is the lane and which part of the segment of the lane is basically it has to move, and identifies the track. Then it sees whether an object is there. Let's say a traffic signal, then otherwise a stop signal, or maybe a passenger is there. It stops and then basically detects the object. After detecting the object, it should also not only object detection, it should also variate its speed, how it's going. So we have the MPU 6050 over here, basically gathering the speed data. After that, let's say object is in between. It's let's say far right now. You have to slow down, right? So the whole overall process has to like gather the data from the sensor and then stop it like before it reaches to that particular object and avoid collision basically. Right. And after that, we have like lane pixel identification. Then histogram analysis comes in a deeper level of image processing. So basically, what it does, it processes the image, and let's say the graph is very histogram is something like a bar chart. Let's say it's very usually in any kind of normal implementation, it's concise to a particular point duration. Using image transformation and analysis, you have to filter out the noises. Let's say Gaussian noises, blurring, de-blurring noises. After doing that, you basically get the graph for overall like marginalized pattern. And basically, polynomial equations, and this is one of the basic techniques, right? After that, we have path planning. So you got the path, right? Now you have to follow it through and reach your objective goal. Also identify which is the start position and end position. Apart from that, um, yes, so we have like even virtual physical demo. Let's say we have simulations. So the application software is a browser-based application system, which you can just have like fully operational courses also, and you have like upgrades. So you can have a first demo over there in the environment. You can also have a digital twin of AutoAuto that you can simulate inside it. And beginning with it, we have like some demo sessions that are given over there on the website of EduTech. So basically, like, you can just identify like whatever object, let's say computer vision and neural network. So the next level, let's say what is of this is basically artificial neural networks to classify the objects that are over there. Since it's a Raspberry Pi inside it, you have to basically see what is the capacity. Since it's an edge vision, right? So you have to use, let's say, lightweight models that are actually pretty good and are. It's not like you have to be always like using high-fi level, let's say YOLO models, which are heavy weighted, which cannot run on edge devices. You have to run some, let's say, optimized algorithms over there. So, uh, considering that, like a short demo of the application software, you have the simulation over there. So it gathers the data and then maps it over. So you can just run it over there and put your code, whatever code you have developed, and you have to be like a segment wise, and you can do. So then it's used basically Python. So basically you want to save your work. And we have even, let's say, opportunities like data science or AI, you can incorporate inside it. Apart from that, we have a modular approach that is followed. So the application basically operates as ID as usual. And we have a live virtual world that gives a 3D simulator for the students to navigate and our physical workflow will basically map, okay, how what is we have module wise sections. This like basically loops are also to say, okay, if an object comes and it should either take a left or a right, and if there is another obstacle over there, what should it be done? And stepwise, like you know, loops, like what should overall the progress. Then we have feedback sessions also. So that's all, guys. Any doubts, clarifications, if any? No, thanks. Yes. Thank you. Guys, as of now, we are completing the